students, my name is Theodorus Gazal. I'm your physics teacher. Today we'll see work energy and power. Work energy and power, that's unit 5 of grade 11 physics. There is some basic terms and equations are listed. Let's leave that and work done by, let us start from seeing work done by a constant force. Always work done by a constant force is the dot product of the force and the displacement. And as you know, if it is dots, by cancelling the dot product or the dot sign, you can add what? Cosine. That means work is equal to magnitude of force, magnitude of displacement times what? Cosine of theta, where theta is the angle between the force and the displacement. Therefore, by using this, you can determine the work done. Work energy theorem. From work energy theorem, work and kinetic energy have a relation. That means work done is equivalent to what? The change in kinetic energy of a system. That means the kinetic energy final minus kinetic energy initial. And also you can write this work is equal to, by taking 1 over 2 m as a common, v final square minus what? V initial square. This is the equation which we use to determine the work. That means which links work energy, work and energy, work and kinetic energy. The third one is gravitational potential energy. Here, kinetic energy and gravitational potential energy has a difference. Kinetic energy is an energy which is possessed because of the movement of an object. That means because of the speed of an object. And gravitational potential energy, since in general potential energy is an energy which is possessed because of what? Position change. Therefore, as you know, work is equivalent to what? Force times displacement. And the force in this case, since it is gravitational potential energy, F is equivalent to what? Force of gravity. Force of gravity is equal to what? Mass times gravity. Therefore, work done by gravitational force is equal to mgh. And this one is equivalent to what? Gravitational potential energy. Therefore, gravitational potential energy is equal to mgh, or potential energy is equivalent to mgh. And the fourth point is constructive forces, conservative and non-conservative forces. When we say conservative and non-conservative force, the force here to be conservative is the work done by the force does not depend on what? The path they take between 2 points. If we have 2 points, if we move in such a pattern or in such a pattern, or we move in such a pattern, either 1, 2, 3 ways, in each way or in many ways, if the work done is independent of that path, we can say the force is what? Conservative force. But if it is path dependent, it's what? Non-conservative force. Therefore, conservative forces are to do work, they cannot depend on what? The path, or they are path independent. But non-conservatives are what? Path dependent forces. Okay, since they are path dependent, if it is a closed loop, there is no work done in non-conservative forces. The other thing is conservation of mechanical energy. When work is done on a system, we can say when work is done on the system, the energy of the system changes from one form to what? Another form. But the total amount of the energy remains constant, because always mechanical energy is equivalent to what? The sum of what? Kinetic energy plus what? Potential energy. In some manner, kinetic energy becomes 0, or in some manner, potential energy becomes 0, or in some situations, both are different from 0. But always in the 3 or in all situations, the mechanical energy of the system is unchanged or constant. It's sometimes when, for example, when kinetic energy is 0, all energy is converted to what? Potential energy. And when the potential energy is 0, all energies are converted to what? Kinetic energy. That indicates all energies are expressed in terms of kinetic energy. But the total mechanical energy of the system is always what? Constant. There is one example. Depending on the conservation, you can see and do by yourself. Let us see. Power. As you know, power is work over time, but in general power is energy over what? Time. Energy over time. We can also express power in terms of force and velocity, because power is equal to work done over time, and work is equal to what? Force times displacement over time, and this part is equivalent to velocity, therefore it becomes what? F times velocity. Power is also force times velocity is another equation of power. And here another point, that is work done by variable force. Always to do work done by variable force, you must treat by using force versus displacement graph. First you must take the values and draw the graph, and you must take the area. For example, for this is the area, this is the area of the graph. You must take this area to determine the work done. You must use this to determine the work done. Therefore the work done is the area under the graph. Therefore you must take this area by dividing into different segments. You can divide in such a manner. This one becomes rectangle, this part, and you can divide this as triangle, and this as rectangle, and this as triangle, and you must subdivide into different area segments into rectangle and triangle. After that you must calculate the area of each segment and sum up to get the total work done. Supplementary section, this one is supplementary. You can see by yourself the supplementary parts, and this is all about work, energy and power. Until next time, have a nice time.